Hi, my name is Juliana Careaga. My mentor is Yingtong Amanda Wu, and my project is how climate change affects the granular poison frog in Costa Rica. A little bit about me. I'm an incoming senior at my high school located in Chicago, Illinois, and a reason I chose this project was because I have an overall just love for nature and science, and I thought it would be super interesting to be able to pick a species of my choosing and research it. So the goal of my project is to analyze the effects of climate change on the granular poison frog, also known as the Ufaga granulifera, specifically located in Costa Rica. And so a little bit of background about this species. So amphibians, just overall, a large portion, 43%, are experiencing declines in their populations, and this is globally, and these conditions just continue to worsen. And so a lot of factors that cause the decline in population include habitat destruction, the drainage of wetlands, the rise of urbanization, and the spread of pathogenic fungi. This species, the granular poison frog, is listed as an vulnerable species in the IUCN Red List. And the one I'm examining in Costa Rica, a lot of its population declines are due to habitat destruction or habitat changes. And a lot of this can trace back to possibly climate change, which is what we're examining, as climate change can cause prolonged droughts or increased temperatures that lead to reduced number of wetlands, which reduce the number of potential habitats for this species and put them in threat. So just overall, what I'm trying to investigate is whether or not climate change affects these population declines and or causes it. So using this information, as well as using R coding and available occurrence records, I developed a species distribution model that displays potential distribution and habitat suitability for the granular poison frog, specifically in Costa Rica. And if you look at the figure on the right, this shows current and suitable habitat for the granular poison frog based on this data that we've collected. And if you see on the left the current suitable habitat, you can see so that green area represents suitable habitat for the granular poison frog, and you can see it's pretty limited. And then if you look on the right, which represents future suitable habitat between the years 2060 and 2080, you can see that that area has increased and spread throughout Costa Rica. So what does this tell us? This tells us because the model only takes data based on climate change, this tells us that climate change is not a threatening factor for this specific species of frog. There may be other factors that lead to their subsequent decline in population. However, the increase of suitable habitat area between A and B, as we can see, increases and therefore shows us that climate change is not necessarily a threat for the granular poison frogs compared to maybe other threats that may lead to their population decline, because as we see, climate change is not one. And so we know these results are accurate because if you look on the left of the ROC, or area under the receiver operator curve, this shows us that the AUC is 0.995, which is very close to 1, which this tells us this is a very accurate classifier and distinguisher between the positive and negative cases of the data, and therefore we can trust that this is a promising model and that it is an accurate one. So overall, this data tells us that climate change is not a threatening factor to places of habitation for the granular poison frog, and therefore shouldn't contribute to their ultimate population decline nor worsen the situation. So thank you for taking the time to listen and learn about my project, and I hope you learned something new or found it intriguing.